Today we're starting Unit 3, which is primarily a study about parallel and perpendicular lines and how other lines interact with them. In particular, what kind of angles are created and what kind of relationship those angles have. But before we look at those relationships, we need to be able to describe, how things are placed in the diagram. So one big term that you're going to hear me use a lot this unit is the word transversal. And so that word transversal really means any line that intersects any other two or more lines. So depending on our perspective, different lines in the same diagram could be considered a transversal depending on which other angles and which other lines you're going to be looking at. So let's look at this from the perspective of, well, what angles are around that transversal? Another way to think of this is when you're trying to determine what kind of relationship angles have, look for what line they both touch or what line is kind of involved in creating those angles. So the first problems that we're going to look at over on the right-hand side, name that transversal. We're going to look for those two angles and then where or what transversal touches or kind of makes up the sides of both of those. So our first pair, angle 1 and angle 12. Well, what line do they both touch? Well, that bottom piece of angle 1 and that bottom piece or top piece, those touch two different lines, J and K. But what line is in common between the two? Well, common line is line L. So line L is actually the transversal. Okay, let's look at another pair. 3 and 6. So angle 3 and angle 6. So again, what line does it look like both of those angles touch? Well, they both touch line J. So J is the transversal. Okay, how about 7 and 15? So angle 7 and angle 15. Well, both of those angles actually touch line M. So line M is the transversal. And then what line do you think is the transversal for 12 and 14? Well, 12 and 14, if I look at the sides of those angles, again, both of those touch line K, so line K is the transversal for that one. Alrighty, so now let's look at some of these other pairs, and this is what we're going to refer to most often when we're looking at this unit and talking about relationships of angles and using those to solve problems. So our first step that we're going to look at is corresponding angles. So corresponding angles are angles that are in kind of the same location of an intersection. Now this might be a little easier to see if we just look at one transversal at a time. So I'm going to go ahead and cover up the right-hand side of my diagram. And right now, let's just look at transversal L. And so we have angles 1, 2, 3, 4, 9, 11, 10, and 12. And so the first angle that I'm going to pick out, let's just pick out angle 1, because why not? Okay, so angle 1 and angle 9. So notice if we have two separate kind of intersections, the top intersection with angles 1, 3, 2, and 4, the bottom intersection with angles 9, 11, 12, and 10. The angle 1 and angle 9 are actually both in the top left. So they're in their corresponding or matching places. So angle 1 and angle 9 is one pair of corresponding angles. Okay, so again, if we look around at the different places in our diagram, then we'll be able to see different pairs of corresponding angles. And actually, what if I told you that just looking at transversal L, we actually have 8 pairs that we could name? So let's write one more pair down just from this scenario. So what about angles 4 and 12? They're both in the bottom right portion of the intersection. So angle 4 and angle 12 make corresponding angles. Okay, so let's remove those marks. And I'm going to go ahead and remove my box. And let's look another section. Again, let's look along transversal J now. So let me cover up this piece. Okay, so along transversal J, let's try this with, oops, Let's try this with angle 3. So angle 3 is in the top right portion of the intersection. So the other intersection along J, the 5, 6, 7, 8 intersection, what angle is in the top right? Well, we're looking at angle 7. So angle 3 and angle 7 are corresponding angles. Okay. Let's look at the right-hand piece. So looking along transversal M, again, a bunch of different pairs that we could pick. Start with angle 6. Which angle is in the corresponding spot? So angle 6 is in the bottom left, so is angle 14. Okay, let's try one along the bottom. So then let's cover up the top part of our intersection. And so, again, I'm just going to pick an angle at random. Let's try angle 15. Angle 15 is in the top right, so which one would match up? So angle 15 and angle 11. Alrighty, so let's remove our box and we're going to erase these. Okay, alternate interior angles. If you think about the name, alternate means kind of almost opposite, like alternate sides, opposite sides. Interior means inside. So again, let's go around and just kind of cover up pieces as we go. So if I start just with that left-hand piece along angle, or excuse me, transversal L, angle 1 is not going to work in any piece. I don't even have to finish the pair. So if I'm looking at alternate interior angles, here's what that really means. So that means as I'm looking at my transversal, along that transversal, which intersects these two dotted lines, I want to have a pair of angles that's on alternate sides, but inside the dotted lines. One example would be angle 2 and angle 11. One's on the left, one's on the right, but they are in between those two dotted lines. What about angle 4? What would be its alternate interior angle? That would be angle 9. Okay, let's look at one more pair. So now let's look at, let's see, we did angle 2 and angle 11. We did angle 4 and angle 9. So let's look at one on the bottom now. So if I was to look at, let's see, let me get rid of that. Angle 12, what would be its alternate interior angle? So in the transversal we're touching is K. Our two other lines that the transversal touches are L and M. We want to be in between those lines, but on the opposite side from angle 12. Angle 12 and angle 13 would work. Okay, go ahead, pause the video and try to come up with two more pairs. Now again, there's a whole bunch of different pairs, but just two of the possibilities we could use, for example, angle 6 and angle 15. I could also use angle 3 and angle 6. Again, those are on opposite sides of the same line, the same transversal, but they're in between the two other lines that transversal hits. Okay, next piece is alternate exterior angles. So again, exterior means now we're going to deal with outside. So same thing, if you need help seeing it, cover up part of your diagram as you're working. So just looking at the left-hand piece of there along transversal L, for example, angle 1 and angle 12 would be alternate exterior angles. Again, one's on the left, one's on the right, but now they're outside those two extra lines that transversal L hits. Okay, here's some other pairs to check out. We could use angle 1 and angle 8. We could use angle 5 and angle 16. How about angle 9 and angle 16? Again, one's top, one's bottom. They're outside the two extra lines. Then one other pair. How about angle 10 and angle 15? Okay, next pair that we're going to look at is consecutive interior. So again, two different words. Consecutive, you've heard this before when you've talked about consecutive integers, so right in a row. So numbers like 7, 8, 9, 10 are consecutive numbers. They're right next to each other on the number line. So we can use that same description to say we're right next to each other on the transversal. But notice it also says interior. So one example of this would be, let me switch back over to red. One example of this would be angles 4 and 11. They're both on the right-hand side of that transversal L, but they're in between the two other lines. Some other pairs. How about angle 4 and angle 6? Both on the bottom of line J, inside the two other lines. We could use angle 8 and 15. We could also use angles 11 and 13. Or we could use angles 12 and 14. And again, this is not an extensive list. This is only some of those angle pairs, but you can probably come up with a lot more from that scenario. Okay, some examples of what things don't work. So let me go ahead and erase this. So some examples of pairs of angles that do not form one of these special pairs. First example is angle 4 and angle 13. So here's angle 4 and here's angle 13. Well, first off, do they even touch the same transversal? So right off the bat, if they don't both touch a common line, then they're not going to make a special pair of angles for us when we're using our problems. Another example, how about angles 7 and 10? So again, 7's all the way on the top right of the diagram, 10's all the way on the bottom left. They don't even touch the same transversal. Alrighty. Well, what if they do touch the same transversal? Could they still just not be a special pair of angles? So let's look at, for example, angle 1 and angle 11. So angle 1 and angle 11, we don't have anything with they're both inside the two lines or outside the two lines, even though they do touch the same transversal. But they don't make a special pair that we could automatically use in a problem. We'd have to do some extra work to figure out how those measures are related. Okay, another example that's just not a non-pair. 8 and 14. Again, yes, they touch the same transversal, but they're not both inside, they're not both outside. They don't qualify for alternate interior, they don't qualify for corresponding, they're just not quite lined up correctly. Okay, so what does this all mean? Well, we need to look at how some of these measures are going to relate. So I have a few more examples to go through, but now might be a good time if you need to pause the video, get stuff written down, take a quick lap for a minute before you continue. Now would be a great time to do that. Okay, so let's look at some examples now that we actually have parallel lines and we can start looking at our measures. And again, there's going to be a lot of possible options on here. I'm only going to be able to list a few of them out as we're going through, but there's always going to be more possibilities that still follow the same pattern. Okay, so we have all the same names, and actually you'll notice I added in a few that we've talked about previous unit. We have corresponding angles, which are going to be in matching locations, alternate interior and alternate exterior, so it just changes as to whether we're inside or outside our lines. We have consecutive, otherwise known as same side, interior and exterior. But you'll notice I also put on there linear pair and vertical angles. Just because we're dealing with parallel lines doesn't mean those pairs of angles don't still exist, that we can't still use those when we're going through. So I've grouped these according to what kind of property they'll have if we have parallel lines. So I want you to look at something real quick. So corresponding angles, like we talked about before, we had angles 1 and 5 would be corresponding angles according to the way that we talked about them before. So check out what happens though. This is a slightly different diagram where I still have T as a transversal and I have lines A and B, but in this case, these guys are actually parallel to each other. And so to mark those lines parallel, here's the other thing that we're looking out for. We're looking for these extra set of triangles. And sometimes, you know, some resources might use an extra set of arrows instead, but the same kind of shape. So you want to use those matching triangles to show that you have lines that are parallel to each other. So lines A and B are parallel, and check out what happens if I try to move angle 1 down to angle 5. Huh, wait a second. It translates perfectly. Interesting. So in fact, anytime we have, mark triangles. Anytime we have corresponding angles with parallel lines, they're actually going to be congruent to each other. And we could do exactly the same thing with alternate interior angles. So for example, alternate interior angle to angle 5 would be angle 3. Wait a second. That makes another special pair, doesn't it? So let me go through real quick. Alternate interior is going to be congruent. Alternate exterior is also going to be congruent because we could do the same thing. We could pick up one of those angles and place it in the other location. Consecutive, actually, let's list these angle pairs out first. So a couple corresponding angle pairs. We could have angle 1 is congruent to angle 5. We could have angle 3 is congruent to angle 8. But again, those are only 2 of the possible pairs. There are more pairs that we could use. Alternate interior, we could use angle 3 and angle 5 are congruent. The only other pair that we have on this diagram, though, are angle 4 and angle 6 are congruent to each other. Because we don't have the extra lines, the extra transversals, we only have those 2 pairs for alternate interior. And kind of the same thing as for alternate exterior. So angle 1 is outside kind of that interior section that A and B make in between them. They're outside the lines. So angle 1 is alternate exterior to angle 8. We could also do that with angle 2 and angle 7. And again, those are the only 2 pairs that we could do on this diagram that has a single transversal. Okay, next piece, let's look at consecutive interior and consecutive exterior. So again, consecutive means kind of the same side. So if I was going to look at angle 2, so, we're going to do interior first. So what other angle actually do I know has to be congruent to angle 6 just based off of what we talked about? In fact, I could just take that angle and move it right down to angle 6. Angle 2 and angle 6 are corresponding angles, so I know they're going to be congruent. So if I started with angle 6, consecutive or same side interior angles means I'm going to have an angle same side of the transversal, but it has to be inside. So we're looking at angle 3. Is there any way that you think angle 3 and angle 6 can be congruent to each other? Well, unfortunately, one's acute, one's obtuse, they're not going to be congruent. But as we'll look at this a little bit more when we start playing around with our angle measures, we can actually say that those are supplementary angles. So if I put those 2 angles together, and by the power of technology, I can actually do that. So let me draw in angle 3. And then I'm going to move angle 3 over. So here's angle 3. Let's move him over, sorry. I need to zoom in a little bit to do this. So let's do that. So angle 3. So if I move that down, and I'm actually going to, let's see, let me put it right here. Wait a second. When I put those 2 together, we have our adjacent side in the middle. Those make a nice straight angle. So that tells me if they make a straight angle, what should they add up to? 180. And I could do that with any of these pairs. Let me move him back up. Alrighty, so supplementary angles, I could do angle 3 plus angle 6 equals 180. For same side interior, we also have angle 4 plus angle 5. will add up to 180 degrees. And we can do the same thing with the exterior angles. They are also going to be supplementary. So we could do that with angle 1 plus angle 7. They'll equal 180 if we add the measures together. And the same thing with angles 2 and 8. Our next one on the list is linear pairs. So that's just a holdover from last unit. Again, there are more pairs than I actually have room to list. They are also going to be supplementary, but we could look at angles like angle 1 plus angle 2, or we could look at things like angle 5 plus angle 7 equals 180. But again, there's more pairs than we have room to list. Vertical pair, same thing. So don't forget from our last unit, anytime we have vertical pair or vertical angles straight across from each other, like angles 1 and 3, those are always going to have the same measure, so they are going to be congruent. So we could say angle 1 is congruent to angle 3. Let's pick one from the bottom section. We could say angle 7 is congruent to angle 6. But again, there's more pairs than we have room to list. So let's just practice real quick labeling some of these, and then we're all set. Okay, so on our diagrams, we are given 3 diagrams that have some number of parallel lines with a transversal that hits at least one pair. So in our first one, we have R and P are parallel lines. So the first thing I'm going to do is mark them. So I'm going to put a little triangle next to them so I don't forget, yes, these are supposed to be parallel lines. T is our transversal. We're going to label all of our angle measures, but you'll notice they gave us one already. So they gave us a 75-degree angle. So first off, what other angles do you think are going to be the same measure? Well, let's go back to what we just did in Unit 2. 75, if I match him up with his vertical angle, that's angle 8. So I can label him as 75 degrees. But then let's look at our corresponding angles. What's corresponding to that 75 degrees in that other section kind of on the top left? Well, that matches up with angle 1 for corresponding angles. And then I can do vertical angles again for that one. So then we're still left with angles 2, 3, 6, and 7. So if we again go back to what we know about already, if we're looking at, for example, angles 1 and 2, what should those angles add up to? So if they make a linear pair, they should add up to 180. So I just need to know what's 180 minus 75. Well, that gives us 105. But then I can use the same tricks. Angle 2 and angle 3 are vertical angles, so that means he has to be 105. Angle 3 and angle 6 are alternate interior angles, so they have to be congruent. And then angle 6 and angle 7 are also vertical angles, or I could start looking for corresponding pairs like angles 3 and 7. There's a number of different ways to see which angles have that relationship. As soon as we get going, you're probably going to see a bunch of different relationships jumping out at you. Now, example 2 is a little different. You'll notice we have 3 sets of parallel lines. They already have those triangles marked, so we know they have to be parallel. We are told that angle 7 is 100 degrees, so let's label that. So 100 degrees. So if all the lines are parallel, well, first off, let's go through and label all our corresponding angles. So 7 is kind of the bottom right of that intersection, so every bottom right intersection is going to have that same measure. So that means angle 3 is also 100 degrees. And angle 11 is also 100 degrees. And I can do that again because they all touch that same transversal. Well, now let's see. 100 degrees and angle 3, what does that mean angle 1 needs to be? Well, they're vertical angles, so they have to be congruent. But then I can follow kind of that same pattern, knowing that all of my vertical angles have to be congruent, or looking at all of our corresponding angles. If we know that angle 1 is 100, then so is angle 5 and angle 9. So then our remaining angles, again, it depends on how you want to look at them. Do you see them as a linear pair? So I could do that with angle 1 and 2 being a linear pair. Or I could think of this as my consecutive or same side interior angles. They have the same property. No matter which way you look at it, they would have to add up to 180. So all I need to know is what's 180 minus 100? Well, that's just 80 degrees. And so our remaining angles are 80 degrees. All right, in example 3, it looks a little trickier. So it's kind of like our demo diagram where we have multiple sets. So we want to be careful that we are concentrating specifically on which transversals hit parallel lines. So we only have 2 pairs of lines that are parallel. So looking for the triangles, Y and Z have an extra set of triangles. So I know they have to be parallel. So that means my 2 different transversals, and I'm going to give each one a different color. One transversal is W, so that means any measurements I can kind of copy along transversal W, but I cannot transfer them down to transversal X, so my purple transversal. So everything along the blue transversal can kind of match up with corresponding or, same side interior angles being supplementary. And then everything can do the same thing along the purple line, but we can't mix and match. So along our blue line, we are told that angle 3 is 75 degrees. So which other angles along the blue line are also 75 degrees? And here's your other way that you can do this too. Don't forget, you can use that kind of covering up trick. So if you need to, cover up that bottom piece and get rid of those extra angles, get rid of those extra intersections that might be misleading. And so our 75 degrees can actually go along with, that's going to be the same as the measure of angle 8 and the measure, 75, measure of angle 1 and the measure of angle 6. But then we can do either vertical angles, same side interior angles, linear pairs. What do the remaining angles need to be? And you actually already did the math in example 1. So all our remaining angles on there actually have to be 105 degrees. But then we're going to look separately at the other transversal. So along our X transversal, we were told that the measure of angle 10 is 115. So again, I can label all of the corresponding or vertical angles. So they're all going to be 115. And my remaining angles have to be whatever the leftover is from 180. So 180, take away 115. If you need to, double check it on your calculator. We should be getting 65 degrees. And so all of our remaining angles are 65. So whenever you're labeling these problems, again, take your time, make sure you know which transversal you're using. If you need to, cover up a diagram either with your hand or draw them out on a separate piece of paper and then cover it up that way. But take your time. Do not automatically assume that just because something looks the same, that it has to be congruent. Make sure you can match it up with one of your pairs. We'll practice more with these next week, but right now we're just concentrating on being able to name our angle pairs and being able to label just straight angle measures on these. As always, let me know if you have any questions.